Yes, as long as it's accurate. All right, I'm calling someone. I know at least some people have it. So, I believe Jamie wasn't here last class, so she's exempt from being called today. All right, here we go. Here we go. Mariani. Let's check if you have. You got chosen again. So you will not get chosen on Thursday. If the wheel chooses you again, I actually make it. All right, you got it. MVP right there. Got it called again. Got it right again. Another mark for the class. I won't call you again this week. So if it spins on Thursday, I'm going to spin again. That's 8. 8 out of 12. A couple weeks away, possibly. Yeah. You didn't do anything. You don't have the first step. All right, I'm going to go over the answer. I need your full attention. I did start recording already, so I don't forget. At least I believe I did. Double check if you're signed in that I am recording. It should say on the top corner that it's recording. But I want to go over this real quick because we have a lot to do today. The reaction we have today to learn is not very difficult, or the reactions we have to learn today aren't very difficult, but we also have your first mini assessment at the end of today's class period. And so first off, let's go over the bell word. And so the first question says to give the structural formula of the compound formed when D reacts with H2 gas. Now here they're being a little spicy because if you don't give your answer in structural formula, they will not give you the one single mark this is worth. Even if you have it correct in skeletal or correct in displayed, you must give your answer in structural formula. So when it says that, it must be this way, which is why we spend so much time going over how to write them. So what I did was I started by rewriting D like this. See if this makes sense to you. I rewrote D in structural formula. I did, and then CH, and then CH2. This is how I started. I rewrote this into structural formula. Then I realized I'm adding H2 gas, right? So what that really means is I'm adding hydrogen here, and I'm adding hydrogen here. Do you agree? So that would give me as a product CH3, and then you can collapse them, but you don't have to. CH, parentheses CH3, to show the methyl group. And then here, if I break this double bond and add this hydrogen, this becomes CH what? 2, and then this one is CH3. And that gives me the mark. So that was the first point. Are we understanding this first point? We're good with this? Otherwise, you could have written it. You could have written the CH3 like this, how I did it here, which is actually my personal preferred way because it's the clearest. And but not Cambridge's personal preferred way, but it's acceptable. And then you could have also written CH3 too, like just grouped both of them together because both of these they imagine is hanging off of this one. And so you could write it as CH3 2 and then CH like that. But this is how a few of you wrote it, and this is correct. Let's go ahead and continue to the next one. You guys study your mechanisms. I'm seeing some issues with the mechanism, which means I was going to give a quiz just on mechanisms as one of the mini assessments towards the end. But I'm thinking Thursday I'm going to put a mechanism question on your mini assessment because you need to study them. So expect on Thursday to have either this mechanism or the free radical substitution as some of the marks on your mini assessment. Because if you're forgetting it, and we just learned it a couple of days ago, imagine when you take the exam 6 weeks from now. You're not going to remember all of these mechanisms, are you? You have to review consistently in order for this stuff to go in. So one day of review of 2 hours is not going to do it. That's why these mini assessments are in place for this unit, because there's a lot to know. So where are the marks here? Intuitively, you've got to remember that curly arrows always start where electrons are, because it's making a bond from those electrons. So a lot of you were writing the electron, the curly arrow going from the hydrogen to this because the hydrogen is being added in, and I understand your reasoning, but that's not correct in terms of what you have to do. What they're saying is that the 2 additional electrons here, this bond breaks, and it forms a new sigma bond with hydrogen. These 2 electrons are forming a bond with hydrogen, which means if hydrogen is taken here, you also have to fold this bond over for bromine. So right now I have 1 out of the 3 marks, but there's more to do. What do I gotta also say? How did I know to go to hydrogen? I need my dipoles, right? Need my dipoles, need my curly arrows. Now I'm at potentially 2 marks, but what do I gotta do now? You write the intermediate. So the intermediate is to recognize that your carbocation must be where? It's this one, right? Carbocation has to be here because it has to be in the most substituted carbon. And these are the 2 that potentially could have it. It has to be here. And then if this is my carbocation, if I'm in skeletal, I don't have to write the hydrogen. But what do I have to write on the side? Br with at least 2 dots.
Right, so
you don't have to write all 8. I just feel more comfortable writing all 8 because it's bromine, 7 bins, electrons, gains an electron, so it has 8. So this is the last part right there. Is to go the bromine to electrons going to the carbocation, which gives you this result, this specific result. Yes. Yes. I believe nobody's out, but let me double check. Yeah, you're good. All right. Notice how many marks this is for. That's a decent amount of marks. That's not a short chunk of marks, which is why you've got to study your mechanism. So what did I say about mechanisms? You're going to have 1 on Thursday's mini assessment. It'll be the last 3 points. The first 7 will be reactions. So make sure you study that. All right, last one. And I saw some correct answers here and some incorrect answers here. Some people got this right. Some people got this wrong. It says D. So you got to be looking at the right compound. Reacts with HBr to form a chiral bromoalkene. Draw the structure of F. This was D. So where does the bromine go to give you a chiral product? Your only choices of where the bromine can go to is here or here. If you put the bromine anywhere else, you've technically broken the octet rule, haven't you? Because you're adding something to something that already has 4 bonds. So when you add, you can only add to the alkene. You have to be very careful about this. I saw a few people not doing that, like adding the bromine in other spots. Can't be added anywhere else. It's either here or here. Which one gives you a chiral compound?
The second one.
The one in the middle. So your answer here would have been this. Could you have written this in display? Could you have written this in structural? They do not say what formula you have to write. So draw the structure literally means any type you like. Any type of the 3. Anything that shows the structure. So that means you're allowed to do stick, you're allowed to do structure, you're allowed to do skeletal. Rule of thumb is usually whatever you're provided with is what it's easiest to answer as, because otherwise you've got to translate it yourself. So if given skeletal, I'll usually write my answer in skeletal. If I'm given displayed, I'll write my answer in displayed. But it could be written any of the 3 ways. You won't lose the mark if you wrote this displayed. Yes? All right, so that's that. So here we go. We're going to continue on. I called this Unit 6 Part 2B because this is going to be alkenes continued. There's one more type of addition reaction we did not go over last class. That's a very important one. So today we're going to learn about addition polymerization. And I also fit how do we form alkenes into here. So what reactions will give us a result where we end up with a product that's an alkene. So backwards. So you'll watch your flashcards out. As the other classes, I'm going to give you some time when we go over the reactions to make flashcards. If you don't utilize that time, then guess what? You're going home and you're writing flashcards then. So you've got that choice. But I will give you a little bit of time as we go through to create flashcards on the different types of reactions we go over. So let's go ahead and get started. Remember, I'm stopping at 2:05 to start the quiz. So if the lesson ends before then, that means just practice review time. But if it ends at 2:05, that's where we're stopping to do the quiz. That's going to be every day we have a mini assessment like that. All right, here we go. Here's our objectives. So we are in the focus of alkene. And so it says first, recall. What does recall mean? Recall.
Remember?
It does mean go back to an American, but recall actually means memorize.
Oh.
Memorize the reactions that make alkenes. And so they're giving you a variety of reactions that give alkenes here, that where your product will be an alkene. One of these we already did. You're not going to see us talk about it today. A, we haven't. We're going to learn about this. Elimination. B, dehydration. C, cracking. Did we hear of any of these before?
Cracking.
So we are not covering this today because we already did this in organic part 1. I don't repeat objectives. But you should note that cracking can give you an alkene because it gives you an alkene and an alkane. That's what it does. So we're just going to look at these two types today. Then we're going to be looking at addition polymerization. I believe that the way I put it in the schedule, and I was looking at like how many slides would be enough last night because I'm reorganizing a bit. And these two we're going to spend Thursday going over. And that'll be the last part of alkene. These two are hefty. Remember, when there's a small amount of objectives, that means that they're going to be more intense. So try not to miss class on Thursday. If you do miss class on Thursday, catch up. I'll post the lesson, catch up. Because that is the lesson on oxidation reduction. It's redox that you don't want to miss. Because it will inform a lot of the other reactions in the unit. So Thursday's lesson is going to be super important. FYI. There's also a mini assessment that day. Finally, just a reminder on how mini assessments work. You're going to be given 9 in total. The top 6 will be an exam grade in the grade book, meaning that you can drop the lowest. Your lowest 3 scores will be dropped automatically. So the top 6 will be going in the grade book. Lowest scores could be because you missed a day or because you did poorly on one. If over all 9 you can keep an 80% average, then I'll be bringing some pub stuff for you when we get to spring break, close to spring break. So something to earn as a challenge if you can keep an 80% average over all 9. But your top 6, remember, will be your score for a unit exam in the grade book. So the unit 6 exam has 2 parts: the quizzes, these mini assessments, and then the actual regular Cambridge test. Questions? All right, good to go? All right, breathe in, breathe out. Let's get started. In last class's lesson, I remember we were running short of time a little bit. So this slide was in last class's lesson, and I didn't get to cover it with you, and it was a good question because this is a very common type of question Cambridge gives. And so let's go ahead and take a look at it and see how to answer it before we get to the new information. It says, reaction of propene with water occurs in a 2-step mechanism. They tell you that C3H6 reacts to form a carbocation. Draw structures to identify the more stable and the less stable carbocation. So how would we start this? What would be the best way to start? Draw out propene, right? So start with propene. I will draw it out displayed, but it doesn't matter. You could do it skeletal. You'll get the right answer. Just remember with displayed, you have to count your hydrogens carefully, also with structural. Remember what I told you, if you're 1 hydrogen off, it's just wrong. It's just wrong. Which is the advantage to skeletal, because the skeletal you don't have to count hydrogens. So that is the advantage to skeletal. So this is it. And we're adding steam to it, it says, but it's asking you to give the possible carbocations. What are your possible carbocations from propene in the mechanism? You break the double bond, so you're either going to get a carbocation here, or you're going to get a carbocation here. It has to be here or here. So now you have to decide which of those are going to be more stable, the one on the end or the one in the middle. The one in the middle. So I'm going to go ahead and write that. Instead of a double bond, we write a single bond. And there's my plus. My alternative answer would be to do this. If you didn't want to write it out, that's the answer in skeletal. You see the difference? Either of these are correct. What I wrote in displayed and what I wrote skeletal. Check to see they're the same. And then the other one, the less stable carbocation, will be this one. With the plus there. Or alternatively, that. Another advantage going to skeletal.
Skeleton is worse, right?
It just depends on the question, really. It just depends on the question. Now, explanation. Why is the middle one more stable? What is the proper way to explain this from Cambridge? Go ahead. Right, but the H plus gets added first. It's saying, what is the intermediates? The carbocations are the intermediates before the OH gets added. Remember, if you were to follow the mechanism through, you would have this. This is the mechanism, right? So in the first step, this would be grabbing the hydrogen, not the OH. The hydrogen gets added first. The OH gets added later. It's asking for the carbocation, which is the intermediate itself, not the final result. That's the difference here. All right, so what's our explanation? How do we get the marks? Yes.
It's more stable. The one is stable because we have a carbon that has a charge connected to other carbons, which help the more positive carbon to redistribute the positive charge between all the carbons, making it less stable.
That's a beautiful answer. Beautiful answer, Peter. So secondary carbocation is more stable than the primary, the one at the end. Stable than the primary carbocation. And instead of saying all of what Peter said, which was beautiful, you could say due to the inductive effects of the neighboring carbons, right? Due to inductive effects. Of neighboring carbons, which we also call alkyl groups, so I'm going to write that here. ALKYL, alkyl groups. So where are the marks here? 1 mark for getting these right. 1 mark for saying why due to, and then 3rd mark for saying because of the inductive effects. Or because the neighboring carbons help to distribute the positive charge so that it is more stable. Yes. There's no real names for them. Like first step is electrons grab group, and then you get your intermediate, and then the steps themselves don't have names. That's a great question though. Now, question 2 is at the bottom here. Sneaky question number 2. Name your organic products. What's the name of the products? And it said major product. We learned that last class. What is the name of the major product here?
Well, the thing is formed in the first one, right?
So it's pro, right? And what's being added? The OH, right? Which one is the stable one? The OH gets added here or the OH gets added here? The one in the middle, right? So what would we name that? Propen 2-ol. If you don't put the 2, you don't get the mark. because you have to say that the OH is going to the, yeah, you put it in the front.
So
But you
this
have to
more
indicate
stable
position.
one is always the major?
Yes. More stable, always the major organic product, for sure. Are we okay with this idea? This was the slide I left off on last class that I did not get to complete with you. I just wanted to make sure we covered every type of Cambridge question that was important to cover for each topic. So now we're going to officially begin today's new reactions. And yes, except for the review days I set on your schedule, you will have new reactions to add every day. I gave you a ballpark number at the beginning of the unit. That was just a random guess, like 25. However, a lot of times those reactions can fit into categories. So I think last class we may have done, was it 4? We did something like 3 or 4 reactions. We did hydrogenation, we did HX, we did X2, and we did hydration. That was 4, right? But they all fit into one type. They all add the same way. So when I said like you have 25 to 30 reactions, I meant individual reactions. You'll have less types than that. And so we still have one more addition reaction to do. This one's unique. It's why it gets its own lesson. We're going to be learning about addition polymerization today. So make sure you have your flashcards ready. This is a topic that Cambridge has taken a little bit of information out of, and a lot of the information for this unit is studied at the A level. But this is the reaction of really making plastics. If you've ever heard of plastic before, a lot of us use plastic all the time. Water bottles. They are made of polymer molecules, and the main one, polyethylene, is this. This is polyethylene. So that's the plastic that you use for like plastic bags at the grocery store that are terrible for the environment, to be honest. But we often use them. And so polymer molecules, these are very long chain molecules. And by very long chain, for plastic, it's like 10,000 units. So 10,000 of these repeated over and over and over and over and over again. And so polymers are made out of repeating units. We call those repeating units monomers. Mono meaning one, poly meaning many. You've heard of monomers and polymers before, hopefully, because you should have heard about them in biology. In biology, when you study the different classes of macromolecules, you should have learned your monosaccharides, single sugars, your disaccharides, your polysaccharides. The polysaccharides were your polymers of carbohydrates. When you study proteins, you study that amino acids are the simplest, and then you put a bunch of amino acids together and you get a protein. So this is the same exact topic. Single units linking together to form bigger units. And we're going to learn today how that exactly happens, or at least one of the ways it can happen. And this is through what we call addition polymerization. This is ethene. This is its monomer. But what is ethene? Let's start back. Ethene is what? How many carbons? Monkeys eat field bananas. Right? This is ethene. So when ethene turns to polyethylene, what happens is you have an addition reaction, but instead of something new being added, it adds to itself over and over again. So the way to understand that is this pi bond breaks. Goes both ways. And now you have this. But now you have this and this right there. That's not stable. But what if you connected many of them to each other? What if you had more of this? You could, yeah, exactly. And that's what's going on. And so you get this, and this, and this, and it goes on and on and on and on. And so as these ethene link together into thousands and thousands of units, we now call it polyethylene, when you have many of them. Polyethylene, what we use as plastics. Now, what's very cool or interesting about them, and also not cool at the same time, is what type of molecule is this? Like, what functional group is this? you make an alkene, right? You're making an alkane. What we know about alkenes? They're unreactive. They're resistant to reaction. They're hard to break. You can burn them, but you can't do much else. And so the reason why plastics were even developed in the first place was because of this unreactive, like they're not reactive. So they're good at holding things. That's why you hold liquids in plastics. That's why you hold stuff in your plastic bags, because it's not reactive. It's resistant to corrosion. It's resistant to because it doesn't react. And then that's the idea. But the problem with plastics is that it also doesn't react. So it just sits there in landfills and causes all kinds of issues that you might have learned about if you took environmental management. So going back to this. Ethene is the monomer for polyethylene, which we know well as plastic. Yes, Julio. Yeah, but there's no mechanism here. That's just to give you an understanding of what's going on. Like, there's no mechanism for this. You won't have a mechanism today. It connects to itself over and over again. So this is just looking at it a little bit better. Up to 10,000 ethene molecules could be linked together to make polyethylene that's in your plastic bag that you use every day. This is a easy and it's a cheap process. So that's why plastic bags are either sold for free or some states have started to tax. And some places you go, I think Sprouts is one of them, have started to tax if you buy plastic bags. And that is mainly to conserve for the environment, like to kind of discourage people from using plastics. Yes. That's just in general. So there's like, that's usually just how long the chains end up being. So they'll all link to each other though, so they form bonds, intermolecular forces with each other as well. All right, so this is the general reaction for polymerization, and I'm going to show you how you're going to write this on your flashcard very shortly. But I want you to notice that it says this little n here. You may recognize that from math. When you see a little n in front, what does that mean? It means some amount we don't know. It does. Don't you love it? You have to love it. We use the letter N for like so many different things. Here it means some amount we don't know. And so when you are writing a polymer, you will now write your polymer inside of a bracket. Your monomer, your repeating like unit, repeating unit. And so the strategy is for however many times it repeats, we don't know. So we just write the little letter N at the bottom to say that it repeats N amount of times. Thousands and thousands of times, we don't know. And then we write two lines coming out to show that it's connecting to itself over and over and over again. So basically copy, paste, copy, paste, copy, paste, copy, paste, and you get this over and over and over again. So how do we write that on a flashcard? I have that ready for you. On the front, you're going to write addition polymerization. So you can use your own flashcard for this. I just have it printed so that I can tell you how to do this. So you want your flashcards out now, or if you prefer to just look at it, write it on your paper, go home and write your flashcard, you can do that as well. For addition polymerization, the strategy is you would write C double bond C. The first thing you're going to want to do is recognize that this is also an alkene addition reaction. So it's the same idea of what's going on with alkenes. If I've got an alkene, how many groups that are not the double bond are on this carbon? How many more bonds can this carbon make? Like, you actually know this is the thing, right? This carbon can make 2 more bonds. Do you agree? The best strategy to help you with how to do this is to write those bonds going up and down. Do those bonds have to be to hydrogen? So if we don't want to specify what elements or what groups are there, what could we write? X. Do these two have to be the same as each other? So what can we write that as? Okay. What about these groups? Do they have to be the same as these? So I guess continue with letters, right? B. Q, why not? You gotta be just, they could be different things, they could be the same. So X, Y, Z, and Q might or might not be the we don't know. We don't know if they're the same or not. But they could be different, right? They could be different than each other. So then what happens? When the reaction happens, and I was double, triple checking through the standards for AS Chem. I've been checking the 2022 syllabus. They don't appear to need you to memorize the conditions for this. I'm going to go ahead and write them down, but it doesn't appear that you need to memorize the conditions for this. It could be heat or a catalyst. But you don't have to write the conditions down. Heat can be written as a triangle. Yeah? Don't you love it? Okay, so now here's the important part. This double bond breaks, but only the pi bond. And it extends out both directions. That's what you have to remember. In your product side, it's going to be X, Y, whatever these are, Z, Q. Right, lines going out because this is going to repeat over and over again. And then you write this around it and what at the bottom? N. I'll give you a little bit of time to do that. And we're going to see multiple examples. You don't have to write an example reaction for this one. You just have to write the main type. But if you would like to make a card on an example reaction, you can. And remember, I told you you don't have to memorize the conditions for this one. I've read through the standards a bunch of times, and it seems like that's one they took out from 2022. But they would be heat or catalyst, like just not specified. They call them thermal and catalytic. All right, we're gonna on the next slide. I'm giving some time for you to write down the flashcards. On the next slide, we're gonna start to see some examples. What? We good? All right, we're moving forward shortly. We're gonna start to look at practice questions. I see many of you have written it down. I'm about to move forward now. Let's take a look at some questions. This is actually a pretty commonly tested topic, so there's a lot of questions that I can pull on this topic. And so let's take a look at the first one. This is from paper, which paper is this? Paper 1. Multiple choice life. A molecule of a polymer contains the sequence shown. Tons of stuff. Which of these could possibly be a monomer that makes this polymer? So how would we go about figuring out what is the monomer that makes this polymer? What do you think you should look for first?
A pattern.
Perfect. Look for some repeating pattern. So look for pattern. And I'll help you out with this because it's first one. On this first carbon, I see 2 hydrogens. On this second carbon, I see a hydrogen and a Cl. On this next carbon, I see a hydrogen and a Cl. On this next carbon, I see 2 hydrogens. On this next carbon, I see 2 hydrogens. And the next one, I see a hydrogen and a Cl. Because this is non-symmetrical, the pattern is here. Every 2 carbons, you've got 2 hydrogens and then one that has a hydrogen and a Cl. Because this is not symmetrical, it could have connected either way, right? That's why you see the weird repeating patterns. But you should, you can diagram this yourself just to see that is the repeat over and over and over again. Every 2 carbons, it's 2 hydrogens on one and a hydrogen and a chlorine on the other. So then how would we go back to what is the monomer for that? I'm going to go pick one of these units from the end. How do we go back to what is the monomer for that? How do we go backwards?
You would double bond it.
Yep. All you got to do is go back, right?
Would it be B, the answer?
The answer is B. Yeah. The answer is B. That connects to be the same thing. CH2, CHCl with the double bond. Same thing. Just written in structural. I think I told you this is Cambridge's preferred way to write for the paper one. They like to write all their answers in structural because you could just type them. Yes. Yeah, grab the pen. You're good. All right, more examples. I told you I have a decent amount of examples here. I think I have 3 of them, 4 of 1 of them. Any questions about this, or are we okay with what I did here? Make sense? All right, next one. This checkup is from the textbook, and I remember this one very well because in the year 2018, my students took the paper 2, and a student came back and said, I saw a reaction I never saw in my life. We never went over this. It was word for word. This was the question, but it was word for word. One of the things that was in the textbook questions, like it was the same exact molecule, same exact process. What is my lesson here, or what is the lesson? Go back over your notes when you're reviewing for the Cambridge exams. It is not impossible for textbook questions to show up as actual questions on the Cambridge exam, but they just forgot the whole addition polymerization thing. They were like, we did that. All right. C2F4 is the monomer for the polymer PTFE, which is used in non-stick coating on pans. And Cambridge, by the way, in organic chemistry, loves to drop you with those fun facts, just so you're aware. So just so you're aware, this is what we use for the non-stick coating on pans when we're cooking. The reason why we do is because the carbon-fluorine bond is so strong, it doesn't break very easily, so that's why we use it, because the carbon-fluorine bond is really, really strong. We're going to talk a little bit more about halogen alkene purposes another time, but that is the reason. It's because the fluorine-carbon bond is very strong, so it can withhold very high temperatures. And it's not sticky because it's non-polar. Not sticky. So, first of all, what do we call the type of reaction?
Polymerization.
But that's not good enough. They won't give you the mark.
Addition polymerization.
You've got to say addition polymerization. Which is why in the flashcard I wrote specifically addition polymerization. Unfortunately for you, there's 2 types of polymerization. However, in AS chemistry, you only learn one. So in your head, it'll probably be like, but it's polymerization. Like, what else would it be? There's actually a whole different type of condensation polymerization that is used when making proteins and other macromolecules, actually. And so you're only going to learn addition polymerization in the AS level class. But they do want you to know both words. That's the type. Now, same thing here. It was 1 mark, and they wouldn't give it unless you said
Addition polymerization.
addition. It said type of polymerization, it has to be addition. They already told you it's polymerization, so here you just have to say the word addition. That's the type. And we're back to, this was that question that was on that test that year. They tell you you've got this monomer, C2F4, and it's used to make the polymer PTFE. They want the repeat unit. What does that mean they want? They want this with a little n. That's what they want. When they're asking for the repeat unit, they're asking for you to show whatever's inside here with the little n. So then for C2F4, what would that be? How should we begin?
Double bond with C's.
So first we should draw C2F4, right? So C2F4 is C, double bond C. On the first carbon, how many fluorines do you think there are? On the one on the left? 2. On the one on the right, how many? 2 and 2, right?
Yep.
So what goes in here?
That.
The 2 carbons. Is it a single bond or a double bond?
Double.
The double bond breaks, right?
Oh.
And when you make the polymer, it's now a single bond with the other bond going out like this. And remember how I told you have like a X, Y, Z, U? That would be all S this time. So it would be F, joke that I remember, like old memes, and it kids brought home their grades to mom. Got this. They were like, "Hey, look, mom, carbon tetrafluoride." Like this. They were like, "Hey, look, mom, carbon," and it's like the grades were C, F, F, F. So whenever I see those together, that's all I think of. C's and F's. Grades. Do better. Don't get C's and F's. Does this make sense? Is the answer? We're good with this? Look at how many marks it's worth. One measly mark. Why? Because they're just expecting you to know that that double bond breaks and goes both ways and just rewrite it, right? It's not more than what they would consider one mark of information. Good with this one? All right. This is the bell work. I had left out a question from the bell work, but this is the same as the bell work. It's the same molecule. They're now asking you another question about them. They're saying C can form an addition polymer. What is the structure of one repeat unit? They gave it to you in skeletal. How do you feel about that?
They also gave us to the structural, molecular.
They gave you molecular, but that ain't gonna you can't do anything with that. You have to get it from here. So what would I do? I would rewrite it. I would rewrite it in specifically this form. Like, I would always start with this form, so it's very easy to know what to do. So what does that mean? I'm going to start by writing my two carbons through the double bond base. That's where I'm going to start. So I rewrite this as C double bond C. The carbon on the left has what groups?
CH3
On the top,
and CH3.
on the bottom. So that would be my X and my Y, right? And on the other side, what are my two groups?
CH2.
CH3. Because this is still a methyl, right?
Oh, yeah.
CH3? No, there's something here. That carbon don't have 3 bonds. What's down here?
H.
Oh, an H.
How many? 4 bonds. I'm gonna leave that up there for all your mini assessments and your tests. Double check you don't give me anything where carbon has 5 bonds. Double check. You don't get that on the Cambridge exam, but like, yeah, no, carbon makes 4 bonds. All right, are we done?
Yes.
No. We don't have to mark.
Oh, yeah.
Do you understand how I did this and why I did this? Like I transformed this from skeletal into some kind of structure to match how we are memorizing the process goes. So now we know we're gonna break the double bond. Literally, if you had a pencil, you could just erase and then just extend. But remember, Cambridge doesn't allow you to use pencil, so only I would like put a box around my final answer. Make it clear to the examiner that you're presenting them your final answer. So this, what else do I gotta do? I don't have my mark yet.
You gotta make it bond to another one. Oh, you put it bracket.
You don't have to show it over and over again. So this one. This is the repeating unit by definition. This is the repeating unit, right? Just to understand. If they said drop 3, so the bolded 1 here was to kind of give you the clue. Just write it once. If they said write it 3 times, what would you have had to do?
Right.
This connect to this. Copy paste. That's how I view it in my head. Look. Yes.
What if my CH3 is out of the parentheses? Would that be still correct?
What do you mean out of the parentheses?
It's like the CH3 is not inside the
Oh, that's okay.
That's okay?
They would accept that. That's clear what you've drawn. They did not say what format they wanted it in, but you have a repeating unit of 4 carbons in the 2. Like you have CH2, CH2, but notice I have CH2, CH2, CH3. We have different answers. I have methyl groups sticking out of mine. Because I'm like, look, I only have 2 carbons. These are methyl groups. You have a 4 carbon chain. We're only expanding at the alkene. So it expands here and here. The rest become methyl groups. Does that make sense? It has to be at the out. This forms the center of your repeating unit. So these transform into methyl groups in your polymer. So you don't have 4 in your repeating unit. Yes? Anybody else have any questions about this one? Good with the strategy? We got one more. I like to do a lot of examples because then you can see the different situations that occur. For practice, yes. So, especially in this section, you've got to practice, which is why you need to go to your flashcards. Go to your flashcards often, review, do your homework, stay on top of it, because this unit is going to, it's not that any one lesson is hard, I think I've said this before, but it's that it's a lot, and it's going to compound as you go through each lesson. All right, next one. We've got some fun facts. Cambridge dropping some more fun facts to you. They're telling you facts are compounds made from glycerol. Anybody have any idea what glycerol is? Doesn't matter because it's not the bio class. And unsaturated carboxylic acid. Pentenoic acid is an example of an unsaturated carboxylic acid. Why do we call it unsaturated? Yep, that's what that word means, just to recall. That's 4-pentenoic acid. First question is to give the molecular formula. Well, that's a question. How do we get that? What's the molecular formula? What's the molecular formula? Of our types. What is it? You count everything, right? So it's your carbons, your hydrogens, and your oxygens in this case. And then we just count up how many we have and fill in those numbers. So how many carbons do we have here?
1, 2, 4.
5.
There's 2 CH2s.
Oh yeah.
1, 2, 2 more, 1, C5. I actually, when I was going, if you want to, you can rewrite it in this plate if skeletal's bad for you. And then expand this. It's CH2, CH2, COOH, right? 1, 2, 3, 4, 5 carbons.
Okay.
You see where it is? The 5? How many hydrogens? I got 8. Are we good with 8? Everybody good with 8? How many oxygens? What level question do you think this is? Like if it was a level 1, 2, 3. This is level 1. This is as easy of a question as they can give you. I could give this to free, I might. Like when we do the organic section. Molecular formula is just add up how many you have of each. Draw the repeat unit of the addition polymer that can be formed. So this is our new stuff that free is cooking. Draw the repeat unit of the addition polymer. So what do we do now? What's the idea? What's the best way to go about this? Start at the double bond. Write those 2 carbons. Transform it into the way you want it to look, so it makes it easy what you have to do. These 2 carbons, these 2 carbons. On the left-hand 2 carbons, what are my groups? I'm calling them groups, but I know that they're only single hydrogens, right? Just an atom of hydrogen there and an atom of hydrogen there. On this side, I got a hydrogen at the bottom, but I got all this stuff at the top.
Yeah.
And it ends up becoming just a side group. Like, that's not, you gotta write it, but it's like not like part of your chain. It's just a side group. And so now, how do we draw the repeat units? Break that bond.
Yeah.
Only the pi bond. The weak bond is the pi bond. The sigma bond stays. And so now when you break that bond, you're going to get C, C, H, H. And you don't have to show that you're breaking the bond. There's no mechanism you need to memorize here. So if you're good at doing this in your head, you can do it in your head. I would just advise writing it if you're unsure of how to format it correctly. Not that it's a terrible bracket. I did the same thing, but I was like, how do I capture this into that bracket? Terrible. But you get the point, right? Bracket here, bracket there. Let's try to capture it in the bracket.
Do you always have to do it like that?
Structural?
Like this type of-
You do not have to. You could have written this like just boom boom.
Right, and then the CO
Like
way
that.
to make it show.
Which
Yeah.
doesn't have to stick out of the bracket.
What do you mean?
The little one.
Yes.
Oh.
We call these dangling bonds.
So if that's not sticking out of the bracket. it's
They may not give you a mark, yeah. That's why it's in the structure, like what you gotta do here, like in the flashcard. Yes, they have to extend that. It has to be literally what you saw me write is what you have to do. These are, they actually have a little name, they're called dangling bonds, meaning they keep going on over and over, but dangling means they're just there, you don't know what they're going to. We do, because this repeats over and over again, but like it's there, yes. It could be either. It's a good question. Fans always with those good questions. Thank you. All right, so that was the major category of reaction we need to cover today that there's a lot of questions about. But there's more. Unfortunately, we do got to fill the time that we have, and I only have so much time to do so many reactions with you. So the other types of reactions I'm going to cover with you today, and I think be happy I stopped here, like these next 8 slides, because the other topic that I'm leaving out, oxidation, I told you, come on Thursday, you gotta bring coffee if you have to. Like drink a coffee that morning if you have to, but you gotta pay attention to what I do there. Because if you pay attention to it correctly, it could be easy if it clicks. But if you don't get it, it's gonna be a ton to memorize. So I have a way to simplify it. The group last year that was here and present, they got it, but then weren't here. It was bad. Yes. To Thursday? Did you vote for that?
Yeah.
Well, come with brains, please, on Thursday. Come with brains. Oh yeah, watch the video on it. I'll record it again. I do that for you all. On Thursday, yes.
On this.
On today's lesson and everything beforehand.
Oh, right, because it stacks up.
It stacks. Like this is a stacking set of mini assessments. There's more. Today's is the
told
easiest
you to
least
take a
reaction.
test today and to let those people who didn't come.
Okay, it's okay.
I literally.
I did the arguing, but it's okay. All right, here we go. We're gonna continue.
Yeah, I had my head up despite what she said.
It's fine. Everything's fine. What? So, in the objective, it actually said the first thing about alkenes is how to form them. And so what do we mean by formation of alkenes? We actually, when we were studying organic part 1, we learned about types of reactions. I'm going to just tell you what those types were to remember. The types we studied, we only spent a little bit of time going over them. But we studied addition. You remember what that was? Addition meant adding to a double bond. Have we been doing addition reactions the past 2 class periods? Yes. So that type of reaction we have just spent a lot of time going over.
Eliminate.
The next type we learned is what you're going to see now, which is called elimination. Elimination. Elimination, you may or may not remember, was when you get a double bond as a product. So if you make an alkene as a product, that's elimination. So your product will always have a double bond. So this is making an alkene. We call that an elimination reaction. We'll go back over what that exactly means very shortly. What were the other types that we just looked at the types? Substitution, and we actually did look at one of those. We looked at one of those, but there's more we have on substitution. We learned substitution. We learned it existed. That one thing swaps with another thing. What were the other types? Hydrolysis. And that's gonna be one of the other lessons that, like oxidation, the hydrolysis lesson is one you can't miss. If possible, or watch the video, and watch the video a second time if you need to. Because that was the one last year some students were out for college tour that day, which is one of the reasons I'm not doing a lesson on college tour. And that topic was like 6 points, 8 points of the actual paper too. That topic, last year. So that was another one that was like, it's a big topic. And so I'm trying to choose the date. I cover these stuff very carefully. And then there was another type, hydrolysis, and the other one is redox, right? Which we're going to start covering on Thursday. And so all of our organic reactions, they fall into these 5 types of reactions. So they fall into these buckets. And so we're going to take a quick look at elimination. First of all, why are elimination reactions called elimination reactions? What does it mean?
It takes away H and whatever
And whatever is crazy.
Take out small molecule, right? From organic molecule. I was gonna take out small molecule from large molecule. But elimination means take out small molecule, right? And so if we look at the example here that I've written, what's the small molecule being taken out?
OH.
Is it just OH?
It's H2O, water.
It's H2O, isn't it? Because when you eliminate, you would have to take from here and here. And then you create a double bond. Or the exact inverse of an addition reaction. Because remember, in an addition reaction, you're adding an H and an OH to the double bond, right? Now we're taking them out. So there's good news and bad news. Do you want to hear first? Unfortunately, there's a subset. So I'm telling you the bad news because that's what multiple students have said. Somebody actually said good news like, the other day, and I was like, wow, things happen. People ask for good news. Wow. Okay, so the bad news is that there are some reactions you just have to straight up memorize, and that's the. What do I mean by that? You don't have a mechanism to study for it, so you're not going to be taught how it happens. It's actually taught at the A level how it happens, but it's basically they want you to know what. So this is a straight up flashcard memorized type deal. So that's the bad news. The good news, I guess, is there's no mechanism to memorize, so you don't have to memorize all the steps of a different mechanism for these. So FYI, that's what's going on here. So. Flashcards. You want me to go back? Sure. Back to, yes. Yeah. So this is the eliminated. If you want to write that in. The eliminated molecule. You gone. You out. Peace. You gotta find what's being taken out. You ready? Get your flashcards out. So, I mean, because they do have to be memorized, that means flashcard time, right? And look, we're actually close to the end. I think you might have some time to study today, before your first mini assessment. Elimination. Elimination just means you go to a double bond. So single bond to double bond. Yes. Yeah, go ahead. We are. I haven't coached you on the flashcards yet. Damani just told me to stay here, so I did. We're good. Okay. So, flashcards, check them out. There are, again, just as I mentioned last time, we've got our major class, and then we're going to have subcategories. So if you want to start with your major class, you could, instead of writing dehydration for your first one, you could write elimination. And then what would you write on the back? What is a standard elimination? What's happening? So how would we write that in formula form? You gotta have single bonds. You gotta have something that can eliminate. So we would call that X, Y. You gotta have something. And these actual types we did back in organic part 1, you may or may not remember. You have to have an alkane and you have to have a small molecule, XY, that you can get rid of. And so then your product here would be XY out. What's left? What is still there if XY is taken out? 2 hydrogens on each. Watch the way I write them. Will Cambridge be super picky? Probably not. But why am I angling my hydrogens this way? Yes, valence shell electron pair repulsion theory. Trigonal plane are 120 degrees, right? If you were to angle your hydrogens a little bit up, I don't think they're going to give you a hard time. But that is the reason why you see me drawing them a certain way, is to show the right repulsions. That's standard. Doubt. To be clear. I'm just telling you why I'm writing them a specific way. But they typically don't say draw the three-dimensional structure here. You have to be careful, like if it says draw the 3D structure, that's usually with chirality. That they'll ask you to show the wedge and the dashes, stuff like that. So here it's just so it looks prettier. Alright, got it? Good type? Take a picture of this if you didn't, because I'm about to delete. Because remember I had something else written here first, right? Remember we used this flashcard for a second flashcard. So we need a picture of this to go back. And so this is a major type. And so just like with addition reactions, elimination reactions have subtypes, meaning what is the XY that we could get rid of? What are the different things we could get rid of? And the easy answer is, well, what are the things we added the other day? What are the things we added? We added water, so get rid of it. We added like these different things so we can get rid of them. And so there's a couple of them. And if you're unsure, I do print these syllabus standards for you. You can check the syllabus standards at the beginning, and they tell you exactly what they want you to remember. And that's what I've decided to cover, is exactly what they want you to remember. So we're going to go with the first one. I'm discarding, delete, going back. First one's called dehydration. So the first subtype of elimination is called dehydration. And the name says it. What are we getting rid of? You're getting rid of water, right? So dehydration really means removal of H2O. Now, if you've studied H2O that it could be written as HOH, this is going to help you. Because a hydrogen is going to be taken from one carbon of the alkene, and an OH is going to be taken from the other carbon of the alkene. So what's really happening is you're transforming an alcohol into an alkene, and you're getting rid of some water. And so this is a transformation to go from an alcohol to an alkene, if that's what you desire to do. So you eliminate this and come up with this in the water. What? Oh my god. I'll class for a little bit and then we'll go back to the flashcards. This is an example reaction. If you want to do an example reaction flashcard, this is an example reaction. But I'm going to go back to the dehydration so you can see the formal thing. What? Yes? Remember you need a flashcard for conditions. So there'll be specific conditions for this reaction. Welcome back. So, pull out your flashcards again. First one, or you should have one that says dehydration on the front. What should be on the back? A reaction of a dehydration, right? So at minimum, what do you gotta have? Water where? Water on an organic molecule. In order to get rid of water, you have to start with water in the molecule. So far, so good? So you would start with an alcohol. Then you have to recognize that your XY is OH. You're pulling the OH off. What else are you pulling off? And it has to be from the neighbor carbon. It can't be on the same carbon. It has to be on the carbon next door. Because that's what's going to form the double bond. When you remove that H and that OH, what's your result? You've right now got C, H, H, C, H, H, plus water. Okay, is this good or bad, what I've drawn?
No.
This is bad.
Double bond. I like double bond.
I took the H and the OH out, right? If I left it like this, I'm totally wrong. This doesn't satisfy the octet rule, and we go back to good old, I removed something, I have to put something in its place, and that something's going to be a double bond. I can't just add hydrogens in without the water.
Double bond.
Double bond, yes? So that's why the double bond gets made, is so that octet rule is still satisfied. When you remove these two bonds, a double bond gets put in. And then, so this is what gets, water gets eliminated in a dehydration. Just think you're thirsty, no water. Hydration, put water in. Dehydration, take water out. Yes? Does that make sense for the first flashcard? Your second flashcard will be conditions. This one's a little bit complicated because there's multiple scenarios that you could use. And Cambridge will mention either of these, so you've got to be aware of them. I'm waiting till I see most of you are done writing. We do have the time, so because if you look at our pace, we're good. We're good on time for today. Yeah, so that's why we're going to move through as fast as you all are done writing. But I'm not stressing. Are you stressing? Quiz. You can drop the bottom three, remember. Then you gotta keep it 80% average. All right, moving forward. The next part would be conditions. You've got two options for conditions. You should write both of them for this type of reaction. So it's this or that. The conditions for dehydration can either be aluminum oxide as a catalyst, heat and humus, which I'll explain that on the next slide, or concentrated acid. When they say concentrated acid, what could I write as an answer? What are my concentrated acids? Were you told to memorize acids at some point in Unit 3? There's HCl, HNO3, H2SO4, or there's a hack. If you don't know which one to use, they accept you to write. Please write this down. H plus. They accept that.
That's an acid?
Well, yeah, it's the definition of acid.
Oh.
H plus is acid. So if you wrote concentrated H plus, it counts. So if you don't know which one to use and you're unsure, you can write H plus. It's a hack I've had that students that I've had have used before that have gotten A levels on their chemistry exam. Not just because of that, because they would like strategize real well, but that was one of the strategies. Is when you pick the easiest thing to do. So instead of memorizing, it could be any of these three, you could just memorize whenever it says strong acid, H plus. Got it? We still have more to talk about acids, but that's going to be in our final unit of study. But for now, yes, H plus is acid. Let's talk a little bit more about what the heck is this. So, reaction takes place when alcohol vapor passes over a hot catalyst of aluminum oxide. And so, what you can do, this is a method of preparing. I found this from a picture from an old Cambridge exam. And so, what you can do is pass the ethanol through. This is a little test tube here. And this right here, they're little like pellets, is the best way I could say them. They're like little, like kind of rocks, pellets / rocks. It's called humus. That can be purchased. And so basically, the alcohol will filter through there and through the aluminum oxide catalyst, and you'll bubble out ethene because ethene is a gas. That's the idea. So this would be the actual equipment setup if you wanted to dehydrate an alcohol. which is actually, I think, something we could do. Now keep this in mind remember we have a lab day. So think about doing some dehydration as a possibility. Because this is not an impossible test. We have these test tubes, we have these little tubes, and you have an upside down measuring cylinder actually. And we would bubble, and you measure the volume by measuring the difference of the liquid water. So it's actually a kind of cool experimental setup to do. If you'll recall, March 15th is the day that I have set aside for us to do a laboratory for organic. All right, so this is the figure on how that happens. Practice Cambridge questions. I think we're almost done. Just practice Cambridge. Yes. Go ahead. All right. I guess there's only bad news here. What's back? Isomers. So which isomer of C6H13OH gives the greatest number of different alkenes? They have to be different than each other when it is dehydrated. Stereoisomerism counts. Uh-oh. So what do you think? What does this mean? Look at A. When we dehydrate A, what is it that we're doing? Removing OH and removing H from the carbon next door. Is there more than one option of how this one can happen? Is there? CH3, CH, CH3. Yeah. Is there more than one form of this? Or is this one form? There's no other option of what you could do here. So, one. Let's take a look at B. Is there only one form here? Is this symmetrical? Where the OH is? Or if I pull this hydrogen, it's something different than if I pull that hydrogen. Isn't it different? So you could either have, and I'm going to write this one. I don't want to draw this blade anymore. I'm just going to do this. See, how many carbons is this? 6, right? If I take this OH, I could either take the one here, the hydrogen on this side, or I could take the one here. Are these the same as each other? This is hex-3-ene. This is hex-2-ene. Are these the same as each other? It says here, which isomer gives the greatest number of different alkenes? Are these two different than each other?
Yes.
These two possibilities. They are different. And I apologize to you because this is about to get more complicated. You got a double bond. What does that mean you have the possibility of? This and trans. Geometric isomers. That's what I meant by stereoisomer counts. So every time you have the ability to have cis trans, you have to multiply by 2. I don't know if you remember that from before, that you actually have 2 variants. One of this can be cis, and the other one can be, so you have cis and trans of this. And then for hex-2-enes, because this is not equivalent either, this is cis and trans. So this is actually 4 variants, which will actually be, by the way. Which one do you want me to analyze now? You want me to do C to prove C not right? Okay, let's prove C. So, you're removing the OH, right? Where could you be removing the hydrogen from? Here, or here, or here. Following me so far? So, if I remove it from the one up here, I'm going to have C, 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 and this is that. Does this have cis and trans variants? Because it's a terminal. It's at the end. These are 2 hydrogens, right? No cis trans. This is one variant. Now, let's say I remove a hydrogen here, and I get 1, 2, 3, 4, 5, and I get this. Does this have cis trans? Yes. Because these two are two different groups, and then this is a CH3, and then there was a hydrogen. So this has cis trans. So this is 1, this is 2 more, that's 3. So why am I saying C is not the answer? Pulling this hydrogen is the same as pulling this hydrogen because the molecule is completely symmetrical that way. And so these are both the second one, hydrogen. Does that make sense? So that means this has 3 variants, not the answer. The answer is B. What level do you think this is? Level 2.5-ish. That's difficult. Why is this very difficult? If you were to get this on a Cambridge exam, I would expect 90% of students don't get this right. Where is the difficulty here? They didn't say to include stereoisomerism. So you wouldn't have thought of it if I didn't bring it in your mind to include it, right? And C would have been most people would have chosen, I think, C is the answer, actually. Welcome back. All right. So there's another way we can make an alkene. Flashcards, one more time. Instead of eliminating water, we could eliminate HX. This is the other very common one you need to know. So this is the, what's the company? It's just called halogen alkane elimination. We could call it halogen alkane. It doesn't have a fancy name. So let's just title it halogen alkane elimination. It doesn't have a fancy name like dehydration. I actually was reading last night. They called it like, and it wasn't from Cambridge. I was just reading an online resource. Hydro dehalogenation. And I was like, I am not teaching that. Cambridge doesn't expect that. It's just an elimination of a halogen, right? Halogen alkane elimination. And so what happens here is your small molecule you're removing is HX. X being a halogen, yes? And so what you have to memorize here, first of all, this is the overall reaction. I think that the products here, you can cross this out. This is just for us HX. You don't have to memorize all of this stuff. It's just HX. And then it's a double bond in HX. So this would, yep, that's a condition. So there's going to be 2 conditions that are really important here for a second flashcard. The condition is that solvent is ethanol, and I would also put NaOH. How I've often seen it written is NaOH alcohol. So meaning you have sodium hydroxide that instead of being dissolved in water is dissolved in alcohol. You're going to learn next week why NaOH and water will actually give you a completely different answer. You won't get this product if you have water. So specifically, there's no water here in this reaction. No water. No water. Yes. So I would say the condition specifically is the solvent is ethanol, but NaOH and ethanol is another way of approaching it. You could say that the conditions are NaOH and ethanol. Is another way to say it. So it's got to be NaOH dissolved in ethanol. And you eliminate HX as a result. So how would I make a flashcard? I'm just going to show you real quick. How would I make it? And then, so the name of this is halogen elimination. And this is C, H, X, H, H. If I've got NaOH in ethanol, what are my products? So what happens here? I have to have NaOH and ethanol. And what do I get? Yes. And what gets eliminated? CHX. Whatever X is with the carbon hydrogen next door. That's how. So it's the same type as dehydration. But instead of eliminating water, you're eliminating HX. And the conditions are different. And you do have to memorize these different conditions, which is honestly the hardest part, is memorizing the different conditions that you need to know. And so we're going to do a couple more practice questions. We're almost done. I think we'll do one more and stop at this last one, to give you a little bit of time. So one more practice question. I still see some writing, so I'm going to pause for just a little bit. You should either write this down or take a picture of it so you know what to write down later on. I'm trying to coach you with how to make flashcards. All right, let's take a look at a practice question, just so we can see one more before we go. Okay. So, this is actually, I think, kind of similar to the last one. It says, this time it's a little bit easier because they inform you that structural and stereoisomerism should be taken into account. So, because they mentioned it, I'd say this is a little bit easier because they're kind of focusing you on what you need to do. They tell you an organic compound X is dehydrated, and it makes 2 organic compounds, only 2. What could be X? I'll let you think about it. So which of these, if I dehydrate it, will only give me 2 products? I'm not going to spend too long. B gives 3. Because it gives you this, and it gives you this, but this has this trend. So it gives you 3. Look at A. It's symmetrical. So pulling this is the same as pulling that. So you would get this as your answer, but that has this trans, which is, and that is the answer, just to be quick. All right, we're going to stop here. You have 8 minutes to study for the mini assessment. Today's lesson won't be included, but the first 2 lessons are. So free radical substitution and alkene addition. Not including today. Yes. Yes, you can. So you've got 15 minutes. You can go through your flashcards. You got a quiz at 2:05. You got 8 minutes. You can either brain break if that meditation is the best thing for you, or you can study crayon.
Initiation, propagation, termination.
All right, I'm testing the homework. This is the homework for today. I think I'm going to do Thursday night to get some time. If you have questions on Thursday.
Alkane halide plus HX. Understood? Okay, plus halogen. UV light. I thought that was the test. Halide.
No, this is your homework. This is the homework.
Alkali highlight.
This is the homework, not a test.
What are the conditions?
This is the homework.
Hydrogen plus halide.
Why do I feel like I'm missing a copy? I don't know why I'm missing a copy, but if you want to do this online, I need to print an extra copy, I think. Yes.
all three of the addition reactions we learned last class will be under electrophilic addition.
Correct. Best practice.
Electrophilic addition.
Best practice study strategy. What's the product?
CH3I and HI.
Correct.
I don't know how to do the arrows. So they're gonna be arrows.
Not today, but there will be next class because they'll be all the do so great on today's homework. So I was like, we're gonna have a mechanism we need to study Thursday. On Thursday.
I saw it. It's been outside.
Yeah, you got that math book now. All right, give me the product.
Okay, it just becomes change.
Oh, that's different than
What's that?
what is it? Yeah, great. Oh. Especially out of and break the double bond. All right, one more. Oh, let's do one of these. These are fun. Let's do this. Yeah. Yeah.
Oh, Ben. You said you would have been.
Why do you mean take some gold? Take what gold? Okay, so what's the answer?
That's a cyclo. I don't know.
Okay.
Yeah, it'll be kind of hard.
Then just put the fluorine on one and put the other one, right? Like that. That's all. You add the one. Yeah. All right, I'm gonna cut this thing out.
You gonna fit all that?
Best practice study strategy.
I don't know how you're going to ask
Pass it by passing it. So that hard.
You stole my pencil already. Okay, you already stole my pencil.
Okay, first one. You would win. Second, I mean, it's like the perfect counter here.
So,
Because
try best not to. So, with the little white one,
all I use is
that's what I used to do.
even my pendulum phone. Your fluid phone.
Best practice study strategy. Get your whiteboard, not today, but like you could get your whiteboard and go like this with each other, like.
You should study more. You guys know all your
What's the
additions?
product? Yeah, no, what's the product?
Oh, you know what happens to each step, right? Initiation, you know what happens, right?
Initiation is the two, they become unstable.
Describe it.
It becomes
The halogen in its natural state, they will have free radicals. It takes some hydrogen from the alkanes and makes a halogen free radical.
I'm taking that personally.
See, I don't think you'll understand the more you look at it.
Oh, no.
Really?
I'm taking that personally. It goes matter soon. Soon enough.
Or whatever structure you want, structure. But like, get a whiteboard, do practice reactions, like, and then over and over again, different reactions, and then once you suck at it, you do it again. I think.
Let's try and see if you can do this thing.
All right, it is 2:03. You've got 2 more minutes. Come on, making you put everything away. Yes.
The halogen in its natural
Do I throw those away? Like the
Precipitate?
the zinc CL.
Leave those. I'll take care of them after school.
What about the HCl? Do I dump it or?
When you're dumping HCl, you have to run water like through it. Like you can dump it, but make sure that water's running. Like don't just dump it without also running the sink, because you don't want too concentrated acid being on the pipes. So you turn the water on in the sink first, and then you dump the HCl down.
Okay.
So rinse with lots of water, basically.
Yeah. Yeah. Okay.
You did a fantastic job. Most of it's done.